After hours of tinkering, I finally got it working. I just had to replace my body with a washing machine. With how 2020's going so far, the end of the world is probably just around the corner. Just in case, I'd better think of a way to communicate with others in the wastelands. But all I've got are some fancy rocks and spare electronics. So I'm gonna make a radio. And on top of that, it doesn't need a power supply. Now I can already hear you asking, can that be done? Yes, it can. To understand why, we'll need to dive into how radios work. The most important part of any radio other than the antenna is the detector, which separates the carrier and the modulator. The detector will depend on the type of modulation that the radio uses. In this case, I want to listen to an amplitude modulated signal, so I want to rectify the signal, turning AC into pulsed DC by using a puny single diode rectifier. But I can't just use any old diode. Specifically, I need to use a crystalline semiconductor diode, which gives the radio its common name, crystal radio. The detector will be made out of a chunk of fool's gold and steel wire. The pyrite acts as an N-type semiconductor, meaning it has an excess of electrons it wants to give away. The steel, however, doesn't have these excess electrons, so when the materials touch in just the right way, it forms a Schottky junction. Due to the different properties of these materials, the resistance to current flow is asymmetric, so that current can easily flow one way, but not the other. You can think of this kind of like a tank under pressure. It's harder to push more fluid into it, but fluid can flow out with ease. This is, however, different from static electricity and is related to band gaps of various materials. The other major component is the tuner, a specially designed filter that will resonate at a given frequency, trapping those frequencies while passing the other frequencies in the circuit to ground. Increasing the capacitance, or the inductance of the circuit, will decrease the frequency at which the circuit is resonant, thus tuning the radio. A simple tuner can be constructed with just an inductor, however more often than not it will have both a capacitor and an inductor, with at least one of them being variable to allow the circuit to be tuned. In this case, I've made a custom 120 microhenry inductor by winding some wire around a failed 3D print, and I put it in series with an 820 microhenry inductor, and I've also added a trimming capacitor for fine tuning. Lastly, I'll need something to listen to the radio with, but normal speakers won't work for this since it's so low power. For this to work, I'll need to use a piezoelectric earpiece, which works by building up a charge across a crystal to make it change shape. This happens just fast enough to produce audio from the pulses coming out of the detector circuit. Alright, so this is my setup I'm going to use to try to capture the audio coming out of the radio. It's super quiet, so I apologize in advance if you can't hear it all that well. Alright, so let's give this thing a try. I am using my body as a ground here, so it may not work that well. Alright, so yeah, it didn't perform that well as expected. Even though my body was ready, it wasn't sufficient to sync the other frequencies. So after a bit of searching around, I've decided the best thing to use is my washing machine, since the chassis is grounded. Alright, so now that it's got a proper ground, let's give it a try to see if it works. That actually kind of worked. It was picking up multiple stations, so it could use some tweaks, but it definitely works. I'd like to improve on this to get some better signal isolation, and to look into low power transmission. But my next few videos will be on some other projects that I'm working on. Thanks for watching, let me know what you thought down below, and if you'd like to see more, consider subscribing to stay updated on what I'm working on.